Hello and welcome. My name is Snehadeep and today we'll discuss about the basics of debugging in this video Debugging 101. So, what is debugging? If you are a developer, you must have debugged your code at some point or the other. You may be using an IDE like Visual Studio or maybe something else. And when you debug, you generally put a breakpoint at some line and then you start debugging and then you go through each line of your code one by one and try to see how it's exactly executing and what is the output of each of those lines. So that's just one way of debugging. There can be many other ways. For example, you have deployed your code already to the production and you are getting some unexpected result. In those scenarios, you can do something which is called remote debugging. Basically, in remote debugging, you attach your debugger, which is running on a remote system, to your process in your production, and then you debug the process. Another type of debugging is called a postmortem debugging, in which an application which is deployed to the production is not functioning as expected. And so you take a memory dump of that process. Then you can copy that dump file to another system where you have already installed a debugger, and then you can open that dump with your debugger and then debug through it and try to figure out what might have gone wrong. So basically, debugging is a way of finding the bugs in your application, right? Your application is not working as expected, and you want to find out what might be going wrong. That's when you debug your code, right? Um, Another very important component of debugging is a PDB file. We also sometimes call them symbols. Those files or symbols are very essential to debug a program. Basically, when you compile an application, it creates a DLL or an exe, right? But along with that, it also creates another file called PDB. This contains a lot of things. You can think of it as a mapping file which contains the map between your instructions in your process to the line of code that actually created those instructions. We'll talk about more of PDB file later in the segment. There are so many tools that you can use to debug your program. For example, Visual Studio is one of the most popular tools. There are so many other IDEs as well. Along with them, you also have tools like WinDBG, which is a UI tool. CDB is a command line tool. Similarly, you have KD, Debug Diag, and a lot more. There can be different types of debugging as well. There is kernel debugging or kernel mode debugging. We'll go into details of these types later on. For now, we just need to know the names. And then we have user mode debugging. In user mode debugging, again, you can break it into two different categories, right? One of them is native debugging, and the other one is managed debugging. Basically, the managed debugging is when you are debugging a managed code or a managed assembly, like the one that you have written in .NET language like C# or F#. or VB.NET, etc. And the other code or the other process which is written in some native language, for example, C, C++, or some other language like VB6, uh, those are called native debugging. When you debug those processes, we call it native debugging. And the third type of debugging, other than user mode and kernel mode, is called tracing options. So basically, it's just um, a bucket to categorize the rest of the world. You can have a kernel mode debugging, you can have a user mode debugging, and then there are rest of the ways that you do with different types of traces and event logs and text logs, ETLs and whatnot. So I'm putting all of them together in this third option, which I'm naming basically as tracing. Types of debugging. So there can be different types of debugging, as I was talking some time back. Live debugging. Um, this is the most common way of debugging. And if you are a developer, you must have done it at some point of time. This is basically when you press F5 in your Visual Studio, and then you go line by line and see what those lines are executing and what are the outcome. So that is called a live debugging. You can do live debugging using Visual Studio, but you can also do live debugging from some other tools like WinDBG, for example. You can connect to a running process, and then you can check line by line or instruction by instruction about how the application is running and what code is actually responsible to run those instruction in your application, right? The second type of debugging, we can call it as post-mortem debugging. So this is the type wherein we have an application running in your production, and then it's not working as expected. Now in production, you will not have access to the code or the source code, right? And you don't even have Visual Studio installed in your production. So in those scenarios, what we can do is we can take a memory dump of the process, and then we can copy the dump to another system where we have all the debugging set up, and then we can try to figure out what might have gone wrong in that application. That is called post-mortem debugging. There is another type of debugging called time travel debugging. So what is that? So when we were talking about post-mortem debugging, remember I was talking about taking a memory dump, right? What a memory dump really is, it's a snapshot of the memory at that specific point of time, right? It's like a picture of the memory at that specific time. So if we talk about time travel debugging now, if postmortem debugging is a snapshot or a picture, a time travel debugging is like a video, right? So we run that time travel debugging, or we take the trace over a period of time, and then it creates a file end of the day, which we can copy to another system and open it in some tool and see what might be going on, right? So if postmortem debugging is a picture, a time travel debugging is a video. And of course, remote debugging, as I was talking earlier. So it is the process where your debugger is installed on a system, and the process that you want to debug is running on another system. And here you basically connect your debugger to the remote process and you do a debugging. Generally, this is a live debugging, because if it's a postmortem debugging, then you don't need to connect it remotely. You can just create a dump and copy it over, and you get all kind of flexibility. But when you need to live debug and you don't have Visual Studio or any other debugger installed on your production, that's when you go to remote debugging, where your Visual Studio or other debugging tools is installed in server A and your process is running on server B, and then you connect and do a live debugging there. So that is what we call a remote debugging. Okay, so as I was talking about collecting a dump, right, in postmortem debugging and time travel debugging. So how do you collect these dumps or memory dumps, right? You can use a lot of tools that are available freely in the internet. Some of them are WinDBG, which we will be talking in detail in upcoming videos. Then we can take dump from a task manager. So if you open your task manager and find your process there in the process tab, you can simply right click on the process and take a memory dump of that process, right? So that's another way of taking memory dump. The third one is called proc dump. So if you look it up in the internet, you will find it out. It's basically a small tool available in GitHub. It's a Microsoft tool which gives you a lot of flexibility of taking a dump. For example, if you want to take a dump of a process when your CPU is 90%, or maybe your memory consumption is a certain number, you can do all those using a proc dump. So you can configure it in such a way that only on certain conditions it will take the memory dump, right? And then we have a very popular tool called debug. Again, look it up in the internet. It's a very popular tool, especially for web application, I would say. And it can be used to take memory dumps. At the same time, it also automates the analysis of those dumps. It analyzes those dumps that you've taken and gives you a summary of what might be wrong. Right? And then we have WER, which is Windows Error Reporting. This is something which is built in Windows. So you just need to make some changes in the registry, and then you can specify the specific process for which you want to take the dump. And based on certain trigger, it will take a dump. So in systems where for some reason or the other you cannot install any other tool to take a dump, WER is our friend, right? Because this is inbuilt in every system. So we can use that to take the memory dump. We'll talk about details on each of them later on. But at this point, I just wanted you to know about some of the very common debugger and dump collection tools that are available in the market. Right? So, when to debug? Very interesting, right? When really you want to debug? One common scenario is when you're not getting the expected result from your application. For example, when you click on a button, you expect to see a message box pops up, but that's not happening. You're clicking on the button again and again, nothing is happening, right? Something is wrong. Now, that's when you debug, right? You try to debug and figure out what might be going wrong. That's one very generic scenario. The second scenario when you want to debug is crashes. So when your application is crashing, now what is crashing? Uh, we call a process to be crashed, to have crashed when it disappears from the task manager, right? The process was running, you did something, or maybe you didn't do anything, but for some reason or the other, it disappears from the task manager. So it died. So that's what we call as a crash. So basically, the process has crashed, right? It's gone. That's another scenario when you want to debug and figure out what might have crashed the application. Right? Another scenario, very common, is related to performance. When your application is running very slow, that's when you want to figure out what might be taking so long. I clicked on this button, it's supposed to get some data from some database maybe, and it still it takes less than a second. But now it seems to have hung, for 5 seconds, 10 seconds, or even more. So what is causing it? So that's when, again, you can debug and figure out what might be causing your application to respond so slow, right? We call it a hang scenario. Now, when we have a hang scenario, we can categorize the hang into two major categories, right? Number one is a high CPU hang. Sometimes you may see that when your system is hung, if you go to Task Manager, you will see that your process is actually taking a lot of CPU. It's taking 70% or 80% or 90% CPU, right? So it's really doing something. It's not just sitting idle there. It's trying very hard to finish something, but it's taking a long time. So that's a high CPU hang. And the other one is a low CPU hang. This generally happens when your application is waiting for some kind of I/O, right? It's waiting for some data from the network. So that's when it's a low CPU hang. So it's if you go to the task manager, you'll see that that application is not taking much of CPU, maybe a couple of percent of CPU, 1% or 5%. But still it's slow. It's not responding properly, right? So that's what you call a low CPU hang. So these were some of the basics. I would say very, very basics that you should know and understand when you start doing debugging, right? So I just wanted to cover those things in this video. In upcoming videos, I will go into much more details in all of these, and one by one I'll try to cover all these scenarios. I'll try to give you some demos and practical examples about how to do postmortem debuggings, uh, time travel debuggings, and different other options. With that, we come to the end of this video. Thank you for watching. Bye-bye.